Well, good afternoon, everyone, or depending where you are, maybe the evening already. Welcome to today's ZEBEX Decarb Lunch series. Thanks so much for joining us. My name is Stefan. I'm the technical manager for the BC Retrofit Accelerator at the Zero Emission Innovation Center, or ZEEC. Today, we're joined by Brendan McEwen from Danske Energy and Climate Advisors. Brendan will be speaking about power efficient design in multi-unit residential building. This is becoming increasingly important topic across BC as more and more buildings add heat pumps, hot water, induction cooking, and EV charging. Electrical demand is rising quickly. And without careful planning, those new loads can exceed the building's existing electrical capacity and trigger costly upgrades quite quickly. That's where power efficient design comes in, and it can help building owners make the most of the capacity that they already have and keep those electrification projects affordable and scalable. The BC Retrofit Accelerator commissioned this guide to help lower barriers to electrification in larger existing buildings. Brendan will walk us through some of the practical strategies behind the guide, which will be launched in July, and we'll be sure to share it with you so you can add it to your summer reading list. We're also grateful to have Jason Rowley from BC Hydro and Jeremy Overton from Technical Safety BC here with us to help respond to questions during the discussion. If you have any questions for the presenters, please add them to the chat as we go. You're also welcome to use the chat to connect with others on the call, share relevant resources or events that you know of, or add comments. Natalie and I will be watching the chat and will be drawing from your questions and comments to help guide the panel discussion at the end. Before we continue, I'd like to take a moment to acknowledge the lands that we're joining from. Our staff and collaborators live and work across British Columbia on the territories of many First Nations who have stewarded these lands and waters since time immemorial. I'm joining you today from the traditional, ancestral, and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh Nations. As we talk today about electrification and moving away from fossil fuels in buildings, we recognize that this work is also about how we care for the places that we call home. I'd also like to thank the City of Vancouver, Natural Resources Canada, and BC Hydro for their financial support to create this guide. Their support helps us to offer these continuing education accredited webinars free of charge. My colleague Victoria will share details in the chat about how to receive continuing education credits for attending today's webinar. Victoria will also launch our first poll now, just to help us get a better sense of who's joining us today. Before we hand off things over to Brendan, I'll give you a quick introduction to the BC Retrofit Accelerator. For anyone who's new to the program, the BC Retrofit Accelerator is an initiative of ZEEC. It's made possible through financial contributions from Natural Resources Canada, Metro Vancouver Regional District, the Roadburn Foundation, and ZEEC itself. Our role is to help support a smoother transition for hundreds of larger existing buildings in BC toward net zero carbon emissions. That work supports climate action targets set by the provincial and local governments. And we don't do this alone. We work with a range of partner organizations, each bringing targeted support for different types of buildings. And I'd also like to give a quick shout out to our two sister programs here at ZEEC, ZEBEX and B2E. They work closely with us on the broader sector building side, including industry capacity, engagement, and coordination. And with that, let's get into the main part of today's session. Brendan, over to you.
All right. Thanks so much, Stefan. It's a real pleasure and an honor to get to chat with you today about power efficient design in multifamily retrofits and how to avoid electrical capacity constraints when we're electrifying a range of different loads. So really appreciate ZEEC for organizing this and everyone in the audience for taking the time. Again, it's a real privilege to get to speak with you. So just a little bit about Danske. We are consultants. We focus exclusively on accelerating the clean energy transition. We don't work directly in designing building facilities, although we have probably more than half of our team are engineers with rich experience in the design and energy services sector. But we work to inform policy, utility, and other sorts of demand side management programs, and also try to facilitate industry capacity building and dissemination of best practices in a range of different sectors. So buildings, zero carbon mobility, industry, and energy. And we were, really grateful, are really grateful to Zeke for commissioning us to develop this guide. And also very grateful for advisory committee members. So thank you to Jason and Jeremy, who are going to join the call from BC Hydro, Technical Safety BC, respectively, as well as Eric and others at Metro Vancouver. And just wanted to note too that the multifamily retrofit power efficient design guide complements a growing body of resources that we're involved in producing under the auspices of the broader Consortium for Power Efficiency. So this is a national scale consortium of different utility, government, and industry partners that are focused on how to advance power efficient design in buildings across Canada. And really appreciate Zeke, BC Hydro, Metro Van, and City Van, and others' contributions to that work. So what I want to use my about 25 minutes today is firstly, briefly cover why to use power efficient design in the multifamily sector and what we mean by power efficient design. I'll then provide a high-level overview of electrical safety regulation in BC, and then speak a bit about the different sorts of building systems that we're aiming to decarbonize through electrification. And then spend the latter half of the presentation just sharing some example power efficient design strategies that relate to right sizing equipment and loads, as well as how to employ energy management systems that can make a limited amount of electrical capacity go farther as we're electrifying buildings. So, as I think a lot of us are aware, the key drivers of electrification in multifamily buildings are firstly rapidly growing demand for cooling, as well as interest in decarbonizing heating, and that is driving demand for electric heat pumps. We also, of course, have rapid EV adoption in BC, and most folks that get an EV recognize that the most convenient place to charge up is where you're parked every night. So there's demand for at-home EV charging and comprehensive future-proofing approaches that can allow all residents ultimately to be able to access at-home EV charging. There's also increasingly concern about indoor environmental health that's driving us towards electrical appliances. So, for instance, moves towards induction cooking, and likely to be growing regulatory pressure to electrify, for example, building performance requirements that are increasingly coming into effect, and other sorts of drivers that are going to be making the most sort of sensible type of systems to implement when we're replacing heating or hot water or other sorts of systems to be predominantly electric. And finally, BC has electrical planning report requirements. So by the end of this year, if you're in southwestern BC, and I believe it's by the end of 2028 for the rest of the province, condominiums have to get an electrical planning report so that they can better understand what the electrical capacity is in their building and how much capacity there exists to provide for EV charging and other forms of electrification, heat pumps, etc., in buildings. So that's, a really kind of key component to this effort towards power efficient design is the ability to provide effective electrical plans as part of these electrical planning report requirements that are going to be of most service to the condominiums that are getting those documents. So, per the electrical codes, electrical circuits in all buildings, multifamily included, have to have sufficient capacity to accommodate the loads that'll show up on them. So the electrical code um, applies to circuits that are downstream of the utility connection point here, and then has rules for how much capacity you have to have available on your service. So that's the main connection to the utility system, as well as feeders within the buildings, and then finally branch circuits out to those end loads. And again, the electrical code dictates how much capacity you need to implement and how large those different sorts of circuits need to be. You can, as you're adding electrical loads, exceed the value for your existing circuits uh, that is calculated per the electrical code, and that can then drive the need to upgrade those circuits. And that can be quite costly. So this is just an example of three different buildings. I was looking at the cost to upgrade the main service to the building, as well as, if necessary, the cost to upgrade the service and the panels to the individual units, or rather the feeder and the panels to the individual units. And, the costs can really vary. Here on average, we're looking at perhaps $4,000 per unit to upgrade that main service. And then something on the order of, five to 7,000 or more dollars when you're upgrading suite feeders and panels is quite normal. So it can be quite worthwhile, if possible, to avoid those types of costs when we're electrifying. The way that it can be possible to avoid or defer those sorts of costs while electrifying a greater amount of loads than might otherwise be possible is through power efficient design. So power efficient design refers to a range of strategies that limit the instantaneous electrical power demand that dictate the capacity of these consumer service feeder and branch circuits under relevant electrical codes. So again, this can be used to avoid or deter those kinds of costly electrical upgrades. And as a side benefit, it can also provide benefits to the broader utility grid and to ratepayers, both through passively lowering peak demand, and it also introduces equipment that can not only respond to capacity constraints at the building level, but can also respond to utility demand response events. So getting signals when electricity on the grid is expensive and throttling down consumption accordingly. So there are, hundreds or thousands of different power efficient design strategies. In order to help stakeholders make sense of them, we tend to group them into four large buckets. Firstly, there's optimizing load calculations. So using load calculation methodologies that are going to better reflect the true demand that might actually be on that circuit. And there's different sorts of calculation methodologies that are enabled under the C code that I'll get to momentarily. Secondly, using efficiency and right sizing to save how much power is going to be used. So efficiency refers to making building systems more efficient. So, for example, having a better quality building envelope or have energy efficient water fixtures so that the peak load you're designing to isn't going to be as great. And then right sizing is choosing equipment and systems that are going to meet a given design temperature or a given energy service requirement, be able to provide that energy with lower power, lower amperage. The third main strategy is energy management systems. So this refers to a range of different sorts of technologies that can monitor how much capacity is in a circuit in real time and then control loads and or sources of energy so that they're not going to exceed the capacity of that circuit. And then finally, there's energy storage systems. So this is charging up, let's say, a battery or a thermal energy storage reservoir, like a hot water tank, when there's available capacity, and then meeting peak needs from that stored energy rather than from, let's say, the building's main electrical service. So, four broad strategies. And in the latter part of this presentation, I'll speak a little bit to the two most common, that efficiency and right sizing bucket, as well as energy management systems. So apologies, this is a bit of an eye chart. I just included this table for the purposes of posterity so that uh, folks would be able to refer to this when accessing these slides into the future. But the key message here is that it's key to plan effectively for power efficient design, and that consultants and contractors and the types of folks that are on this webinar right now really have probably the core role to play in building demand for that kind of effective um, planning for power efficient design amongst condominiums and rental building owners, as well as effectively delivering that kind of planning service for them. So this table has sort of the stepwise types of considerations that need to be made through this process, and then the roles for consultants and contractors, as well as condos, the condo associations, rental building owners, and property managers. So high level, firstly, it's important to consciously commit to planning for electrification. Consultants and contractors basically need to sell that electrification planning service and advise clients on how they will be best served over time by having a good understanding of what the loads are in their buildings currently, how much capacity they have, and how those loads can evolve out into the future. So there's that kind of core commitment. Next stage is understanding what capacity is available within the building. Then evaluating the range of different sorts of power efficient design strategies that can make sense in those sorts of buildings and how they could be best phased and deployed in coming years. Based on having that good understanding of what the options are, then prioritizing the projects and having this documented. Now in BC, that document ideally is going to be your electrical planning report. Depending on the quality of these electrical planning reports that some buildings are getting, they might want to have a further pass at this as we're actually starting to implement some electrification projects. But hopefully, this kind of appropriate level of rigor can be occurring as part of those electrical planning reports. And then over time, implementing those types of electrification projects and tracking how closely energy consumption is adhering to, or electrical peak loading is adhering to what was assumed in those plans and adjusting course accordingly. So I'll say a little bit about electrical safety regulation in BC. The Vancouver Electrical Bylaw and the BC Electrical Code both adopt the Canadian Electrical Code with relatively minor amendments to date, although there is the possibility that future iterations of these documents could have more substantive amendments adopted into them that relate to power efficient design. Under Section 8 of the Canadian Electrical Code, any sort of significant new electrical load, so cooling systems in the building, EV charging, other forms of electrification, require a load calculation to demonstrate that you're not going to exceed the capacity of that consumer service, any of the feeders in the buildings or branch circuits, and that they can safely accommodate those loads. Important to note that some power efficient design strategies are enabled in the electrical code currently. Others require a variance. So notably, right now, the codes allow for you to use electric vehicle energy management systems and control electric vehicle loads so as not to exceed the capacity of circuits, but they're silent on controlling other types of loads. There's a lot of interesting technology out there that is starting to be deployed that control those other types of loads, space heat, hot water, dryers, etc., so that you can avoid or defer upgrades to those electrical systems. And that can save buildings a lot of money. So I'd say electrical authorities having jurisdiction have in BC sought to accommodate some of those variances, and there is going to be an opportunity to uh, update future versions of the code to address this. Notably, the 2027 um, text that was recently approved for the Canadian Electrical Code um, enables the use of electrical energy regulating equipment, is the term that they're chosen to use. If you're using a historical load calculation, which I'll touch on shortly. Now, there could be opportunities to further tweak code amendments so that you can use these sorts of energy management systems even in cases when you're not using that kind of historical load calculation. And additionally, there's perhaps opportunities to reference different sorts of standards for approved equipment that could allow these sorts of technologies to be deployed. Um, so, as I noted, the C code provides two methods for determining electrical capacity when adding new loads. The first is to use a theoretical load calculation, just as would be done for new construction. And this is per rule 8202, which relates to multifamily apartments. Or you can use historical load for all the meters in a building aggregated collectively to give you your peak load per rule 8106 8, sub rule 81068. What you find is that that kind of historical load calculation typically reveals much greater capacity than your theoretical load calculation would have. So this is just an example to that effect. You've got the calculated load here in light blue of what the load would need to be if you're using that theoretical methodology versus the historical load calculation, your dark blue. And so for your main service as well as individual feeders to particular units, you can see there's significantly greater capacity. There's, as we all know, a variety of different types of ways of providing energy services in buildings. And this affects how we plan for power efficient design. So some of these are central, and you would be providing hot water, space heat, space cooling, and ventilation centrally, and needing to make sure that the main service as well as feeder up to those central systems is sized appropriately to accommodate these new types of loads. Some are in suite. So in addition to needing to concern themselves with the main service as well as feeders out to suites, you also need to ensure that each suite panel and feeder has sufficient capacity. And there's sort of variations and different kinds of configurations for what systems would be delivered centrally versus in suite. And this has implications for what types of strategies are going to be the most power efficient and best enable you to defer those sorts of electrical system upgrades. EV loads are really particularly important to consider. They are potentially the largest load in buildings, but also the most flexible. And they're one that is likely to emerge at a steady pace, though accelerating over time. So EV charging infrastructure can be implemented in a couple of different ways. Oftentimes, it's done a few chargers at a time, which can wind up as you do, one tranche and then the other, eating up significantly more capacity than if you carefully plan from the outset for how ultimately all residents would be able to have access to EV charging, or at least consider the sorts of strategies that could accommodate a large percentage of them to have access to charging. So BC's got a first of its kind program, the Clean BC EV Ready Rebate Program, that supports buildings in undertaking what's being called an EV Ready plan or a feasibility study, and then provides incentives that encourage this kind of comprehensive future proofing. And usually the strategies that use that will be relatively power efficient versus kind of unplanned piecemeal ad hoc additions a few at a time. So having this sort of um, plan is, I'd say, a really important part of broader power efficient design planning. And ideally, at the same time, you're considering electrification of major systems like building space heat or hot water, or as you're doing an electrical planning report, you do this sort of detailed EV ready um, plan at the same time. And this will provide you with the best opportunities to make use of energy management systems that are going to be key to avoiding significant load decreases. So I noted that EVs have potentially the greatest load impacts, but also allow, when you're using power efficient design strategies, you to avoid load impacts. Space heating is typically the second largest, and there can be significant opportunities to, through right sizing as well as potentially energy management, reduce those space heating loads. And hot water, particularly in MURBs, is a fairly large slice of the pie and provides significant opportunities as well to avoid load growth. So for the latter part of this presentation, I want to provide a number of examples of design strategies that have been used in buildings, around the province. I'll start with right sizing loads. So again, the key here is first reduce the load, reduce how much hot water you need to deliver on peak, reduce how much your peak space heat will be, and then choose the equipment that in aggregate are going to result in the lowest instantaneous power demand. So in a number of multifamily buildings, just encouraging what's sometimes called low power level 2 is going to be adequate to avoid service upgrades. So you could have a 40 amp dedicated circuit, and that will provide almost an equivalent level of service if you have that amperage to 20 amp. People are still going to get a full recharge the vast majority of the time the next day. So there's ways where you could, in aggregate across a multifamily building, significantly reduce your power relative to this baseline than half that I'll get to momentarily. But even considering these kind of simple, relatively unsophisticated approaches can work in some buildings. This is an example of right sizing central heating system. So we see our baseline here of a central gas-fired boiler plant and an air-cooled chiller. The type of load that we'd see if we transition this to electric boilers and an air-cooled chiller, and then the substantial load reductions versus that electric boiler baseline that you could have if you're using a central air source heat pump with the ability to provide heating and cooling. And this is for a 190 unit multifamily building. You can get even greater savings if we're, in some cases, when going towards switching from a sort of central type of configuration to unit by unit sorts of configuration. So this is the same building showing the type of load that you'd have with that air-cooled chiller. And in this case, you could actually have lesser demand overall if going towards ductless mini splits, potentially augmented by a little bit of that conventional gas boiler plant serving as a backup to meet the very peak. But some serious potential here for reductions while achieving deep electrification. In individual suites, this shows the difference in electrical demand if sort of using typical electric baseboard sizing rules of thumbs versus having a kind of standard ductless mini split type of approach. And then you could get even deeper if you're using right-sized heat pumps, saving you, 3 amps or maybe around 20-25% of the amperage, the power, when you're using that kind of right-sized approach versus more standard types of equipment. And as we have more heat pumps available locally that are able to serve more modest heating loads as well as have greater power efficiency, I'd suspect that we could have in coming years even greater reductions from going towards sort of your best practice cold climate heat pumps. This is an example of central hot water and the importance of sizing systems appropriately. So if we were to assume that your consumption is going to be 185 liters per person per day, which is kind of typical ASHRAE median consumption standards, your central heat pump would be a little bit above 40 amps, whereas it's possible using more realistic sizing estimates to have spec equipment that's going to be substantially lower power. And then when it comes to those in-suite loads, sometimes it can be important to spec dryers and potentially ovens that are going to be lower power to avoid having upgrades to our suite panels. So this shows that as you transition to condensing dryers, you can approximately have the power intensity of your typical 5 kilowatt electric dryer. And if you go towards heat pump dryers, it could eliminate it as there's a 1500 watt threshold for when power is included or not, or when a new appliance is included or not in load calculations. And I'll finish up by saying a little bit about energy management systems. So as I've noted, these systems monitor and control facilities' loads, as well as potentially energy storage or production devices so that they don't exceed the capacity limits of electrical systems. The 2023 CE code only recognizes EV energy management systems. The 2027 C code will enable what they're calling electrical energy regulating equipment to manage loads in existing buildings as well that aren't EVs. So that's progress. But again, there might be some opportunities to further tweak how that's implemented in BC. And there's a variety of different electrical configurations and control schemes that can comprise the broad category of energy management systems. So this diagram shows branch circuit sharing, or in this case, EV chargers share the capacity of a 40 amp branch circuit. And you can supply significantly more chargers on a given, let's say, 200 amp branch panel than you could otherwise as you increase the number of EVSE that share a branch circuit. There's also systems that are predicated on all the switching happening at a panel level, which allows you to implement dumb chargers. And then more sophisticated systems do sort of multi-level monitoring, where they'd be monitoring how much capacity is coming in on the main service, also how much capacity exists on feeders, and then the feeders out to individual units electrical panels. And provided there's capacity on all the relevant circuits, then allows controlled loads to come on. And so especially in retrofit sort of approaches, these can be quite important for making use of the limited capacity that's available in buildings. So this gives a sense, let's say, for EV loads, how those different types of management strategies can be used to reduce your EV load and stay within the capacity limits of a building. If you were to do this in kind of like an ad hoc way, trying to just get dedicated circuits to each parking space, you would exceed the capacity of the building. Having that kind of low power level 2 wouldn't leave much capacity available for other types of loads. But as you get into more significant levels of load sharing on branch circuits or at the branch panel level, and then implementing service monitoring, you're increasingly reducing those EV loads that need to be included in your load calculation and will actually materialize on the peak consumption of the building. And that frees up capacity for other types of electrification to occur. Now, I've noted several times that it's not just EVs that can be controlled. You could also control space heat, hot water, dryers, other types of end uses. So this is a really kind of, I'd say, nascent but active area where there's a lot of innovation, including a variety of providers of interesting technologies locally. These are some of them up on the screen here. I'd say it's still early days for consultants to be thinking about how to implement control of these sorts of loads, but there is kind of a certain priority of loads that's emerging. Definitely EVs are your most controllable. Following that, it might be the case that if you've got storage, like hot water tanks, that it makes sense to control your hot water, although some are first controlling space heating. So likewise, space heating, you can take advantage of the sort of thermal comfort inertia in a building. People are unlikely to notice if a thermostat's been set down for 15 minutes while your oven happens to be on. So you can have these temporary reductions in how much heating output is being provided. And there's been some promising sort of local implementation of energy management systems that are doing that control of space heating. And also it's possible to have other appliances on control. So things like dryers or even cooking equipment could be turned off for a short period of time or allowed to be throttled down in order to be able to handle that peak and thereby avoid those service upgrades. So I'd say this is really something that is worthwhile exploring, and that the best practice is emerging, but that we should be making sure that both the community of consultants and contractors are well versed in these sorts of approaches, and that they're growing rapidly, as well as signaling to multifamily building owners that are planning this, hey, take advantage of these types of right sizing opportunities, do good EV energy management, and then as we're electrifying other loads over time, be conscious that there might be more and more solutions that are coming to market that can help you sort of continue to avoid needing to upgrade services in those buildings where there is a significant constraint and not a lot of power available. So again, in conclusion, there's a whole range of promising design strategies and technologies that can help stretch buildings' limited electrical capacity further. And what we need to ensure is that the practitioners, the industry, have the knowledge and the motivation, the incentive to work to best enable multifamily buildings to implement these sorts of strategies. I hope this has been some useful food for thought, and looking forward to question time. Thank you.
Thanks, Brandon. That was very comprehensive. I really appreciate you putting all this material together for us and for the practitioners to dive into. I'll jump over to Jeremy and ask the first question of the panel. Maybe you could elaborate a little bit on how the electrical code changes could influence or are expected to influence the outcomes of this from TSBC's perspective, and what should practitioners expect in the near term to come their way?
Yeah, thanks for the question, Stefan. So I would say that if we're talking specifically about energy management, it's you can draw a parallel to really any new technologies, and as regulators, we're often at least one step behind, and in the case of new technologies, it can be several more, because in the case of energy management, it's a good example. There's not a mature product standard that allows manufacturers to sort of assemble a piece of equipment and have it stamped as certified as energy management. And the code rules that we have now don't really recognize the use of the energy management systems that are available, even ones that are manufactured here in BC. I think Brendan had a slide late in his presentation that showed many manufacturers a lot of those are designed and built in BC. And we're in a situation where this is for BC, it's really intolerable because there's a huge demand for these products, especially in retrofitting existing buildings, but in new buildings as well, where there may not be a suitable amount of power near the property line to meet their electrification objectives. And so we are working with other stakeholders, other authorities having jurisdiction in BC, like the City of Vancouver, City of Surrey, and BC Hydro, and others to try to find a way forward where we don't have to rely on this 3-year code cycle. Even what's coming in the 2027 code is too restrictive. I think for certainly from the consumer perspective, it seems too restrictive. And so our role is to really find a safe way to enable this technology that can work in BC. And so we're working on that. Right now, the current process is through a variance. Folks apply for a variance to control non-EV loads or to use systems that are certified to other standards for that purpose. That's likely to continue in the near term. In the longer term, the 2027 code adoption cycle, any code adoption cycle is generally the calendar year following the calendar year of the code, generally Q1, Q2. So if it keeps on that pace, that's not really in Technical Safety BC's hands. That's going to be up to the government to amend the electrical safety regulation, but that would put it roughly in March of 2028. And what we'll have there is like I mentioned, not going to allow the use of energy management in new buildings. And so we're looking at what can we do? Do we potentially amend the code before we adopt it in BC or recommend that it be amended? Do we make the variance process much more streamlined and produce guidance materials around that? Do we do some combination of the above? So that's what we're working on. So folks can expect this sort of environment to change and the variance to be a core piece, at least in the near term and possibly the long term as well.
Ties in a little bit with a question that was in the chat, like in terms of like what is available or what has been seen, and I think you answered some of it already. What has been seen in terms of variances frequently, and are those variances then like sort of like available to the public and can be used as a more or less as a template for another application?
Yeah. So in general, variances are not we don't publicize them. They may be available through an FOI request. I'm not sure about that. I believe certain elements of them would be, but we don't publish them mostly because they're not intended to be precedential, right? But this is different, right? We're building we want to build a framework to allow the use of energy management, and even though each individual variance might not be precedential, there's a lot of repeat information in a given variance application, right? There's only so many manufacturers and so many sort of system architectures that you might want to apply these systems to. And so while I don't have that information at hand, I know for sure energy management is going to be near the top. And trying to figure out how to determine just how much spare capacity is left on a service, that's also been a real challenge for designers because we often don't measure that, right? We often have sort of this aggregate data of many meters in a given building, but we don't have a single meter that measures everything going through, and we can't necessarily temporally relate all the data from the meters depending on how frequently we measure the energy consumed. So all that is to say, to me right now, I don't want to overstate what we're going to do, but to me right now, I think there's a real opportunity to put more structure around these variance applications and recognize what's common and give folks guidance as to what to put in there. So that while we won't publish all the variances, it'll be hopefully that would make it simpler for folks to apply for a variance to use this type of equipment while they need to.
Well, I know we could have a whole session just chatting about code and these variances, kind of drawing this back to some of the things that Brendan shared in his presentation. A question directed towards you, Jason, and bringing in BC Hydro and the utility into the conversation, the localized conversation. How have these power efficient design approaches translated into reduced service upgrade requirements? And are there any examples, projects, trends that stand out that you want to share with this group?
Yeah, thanks for that. Yeah, there are projects that we currently have on tap. We do a lot of pilot work right now, to basically trying to understand where, right now in my role here at BC Hydro is to basically bring TSPC and BC Hydro together and work as a team. I mean, it's not like they weren't before, but it was a little bit siloed on the fact that we're a utility, we have our own Part 3 standard, and then Canadian Electric Code lies under Part 1. And there's a lot of things that happen in both those standards that is very conflictive. So we're trying to basically get on tap. We're basically we don't have those wrinkles going forward because that bit produces a problem. But back to the question at hand on do we have data? Yeah, we have some projects that people working. I think some of our product folks here are on this call today as well, that have basically given out really great data. So back to basically what Jeremy is basically saying, and is we have to take a measured approach, but we have to do something fairly soon. We're behind the gun. I used to be the chief electrical inspector at City of Vancouver, so know the Canadian Electric Code fairly well and how constrictive and um, are archaic in some sections that it comes down to. I'm being nice with my words here because I can go a little bit farther on that. But there's things that have to be changed, but it takes a bit of time to get that change across. So with Jeremy sitting where he is right now, with BC Hydro, basically want to partner with a lot of groups out there. We are fully behind pilot projects as much as possible, because the pilot projects will give us that data that will basically give the regulator, in this case Jeremy, basically a better understanding to basically then basically start setting up code rules or variances or amendments to the Canadian Electrical Code under the BC Electrical Code. So that's the push. We're really kind of doing a lot of work out in the market. That we're not sitting idly by. We're very active and trying to partner up as much as we can. We're hoping to have. I know there's some folks on the call today, some contractors here as well. I see. Um, what does that mean about a pilot project? How do you basically apply for something like that? And what's the criteria? And so we're presently working on something that might come out in September, October on some templates and more importantly, basically some funding as well on basically running some more of these pilots to kind of get a lot of these products more out in the market so we can really start try testing them. Another point here, and I'll just jump in because I think it's sort of been asking Jeremy related to is the master meter program. We used to have it at BC Hydro like 20, 25 years ago, and then kind of went away, and then it's sort of still there, kind of on a rebate meter, whatnot. But 100% right that we should have one meter for basically monitoring the power usage of one building going in, and then you can have all your other sub meters off there. That's fine because it will basically give Technical Safety BC a better understanding to potentially basically create a safety factor around multifamily units as well. There's still a lot of work to be done. A lot of data has to be kind of proven on that front, but there's good movement on this. So we are working really tight with TSBC on trying to create this. So we're not sitting idly by. There's a lot of people working on a lot of things. Um, it's going forward. Dunsky is leading the charge on a lot of projects, and Zeke, we're really basically involved with as well on many, many projects. So there's a lot of people kind of understanding that there's a problem. There's some gaps, and what can we do in the meantime? Because as Jeremy alluded to, we can't wait until March of 2028 to start applying some of these code rules. We have to do that fairly soon. So yeah, hopefully that answered the question, sort of. Probably not, probably kind of skirted all the way around it, but anyway.
No, I think you did a good job. I think if you have any other follow-up questions, there was some discussion in the chat about incentives, and that is always a very large topic of conversation, incentives coming down the line. I know, Stefan, you added some incentives that do already exist. So maybe take this as an opportunity, Jason, if there is anything you want to call out to this audience as to are there existing incentives that you feel like, we need to remind folks about that can really assist this work?
Yeah, yeah. Right now we have a couple incentives in place. There is going to be something being rolled out here in the next. I won't want to tip my hat because there's still kind of pieces that have to be brought into place. But we're looking at basically in October some really really good incentives around smart thermostats potentially. Possibly early next year, especially if we kind of get our hats together and figure out how to basically understand some of this energy management systems or EERE systems. There might be a fairly large incentive around smart panel work as well. So that's yet to come. We're working on it, and so expect that. The great thing about this group is that once we can get some information out, we'll basically share the information obviously to the group so that your members here basically kind of will get it firsthand. Um, uh, Yeah, and there are current projects on the EV program here. Obviously, there's a lot of people here that have gone through our EV program, and that's going to be tweaked as well, for the better as well, because it's been a little bit clunky as well over the last little bit. Electrical planning reports. I'm hoping that there are some changes that have happened. Bit of a bit of a stall point. Electrical planning reports are kind of hit and miss on who's doing them. BC Hydro, along with all its partners, are basically trying to tweak that to make it a little bit easier and understanding of that, for going forward. But yeah, anyway, yeah, we do have there are a lot of incentives. Just have to go to the BC Hydro website. You type in incentives for BC Hydro website, and it's just a large list, and you kind of pick and choose your make and model what you want to do there. And yeah, there's lots to choose from there.
I want to bring you back to a couple of, like, in the chat there were questions that kind of alluded to that. Like, obviously new construction is a little bit of a different animal than retrofit in this kind of context. Brennan, you mentioned it before. Jeremy, you talked about that as well. I wonder if we can maybe quantify a little bit, like, of with that like historical load data and the advantage of having that. Like, is there any, like, do you know, like, how many buildings could avoid it? Is it like are we talking about 10%? Are we talking about 50%? Maybe to the whole panel? Do you have like experience or data from that, like, for existing buildings, what is the advantage in practice? How often does that actually happen where that metered load can significantly put you on a completely different starting place than when you started?
So I'm assuming that's questions to me, Stefan. So yeah,
Or
anecdotally
Dansky in
wise,
their
yeah,
work, yeah.
yeah, fair enough. Anecdotally wise, at BC Hydro here, we've heard basically a percentage of basically like 80% of the service that are out there are only 30% used at a usage level, right? So yeah, there is a lot of basic capacity already built in. We got Canadian Electrical Code that's been overly conservative over the years. We have engineers that are conservative as well when they basically design buildings. So there's a lot of conservatism built into these some of these buildings, right? So yeah, there's capacity, and but the problem is though is sometimes, and I'll just say it, like BC Hydro is sometimes a little bit siloed here as well, where we'll go out to a building and obviously the capacity is there, yet we'll be suggesting to basically do an upgrade on a transformer. So that's what we're working on here in BC Hydro to make sure that basically all of our groups and teams within BC Hydro are on the same page instead of basically just going with the stock answer. And that's something I really want to get out. And I know we're kind of getting close on time here, but we have to get away from the thinking of this is the way we've done it for the last 20, 30 years. We have to start putting our thinking caps on. And Brendan brought it up at the very beginning about good planning and early planning on this. We can't expect to basically, look, I'm going to walk in a door, here's my permit application, and walk out tomorrow with my permit. It takes a little bit more than that. So you got to kind of understand that, but you got to put your thinking cap on as well. There is tools. Code can be used to your advantage in some cases. There's standards out there that might be available, but more importantly, you have to basically get out of the mindset of, well, we've always designed it as such. This is how we've always done it, and we kind of have to start pushing the envelope. So that's the biggest thing that we're basically trying to get out there is right side servicing as well. Is instead of basically coming with new and asking for a giant service, because we'll supply it at BC Hydro. Well, it's going to cost you. It might take a little bit of time and energy to do it, but at the end of the day, we will supply that energy. But do you need that much? And that's where we have to really start dialing down. Now, I get it. What kind of tools can we use this? We are working, myself and a few others here, including Brennan, who's the chair of CSA 358. That's the EERE standard. We are trying to discuss what does an existing service mean? Does an existing service mean that basically, well, I have a house that tore it down, I had a 200 amp service there, and that's existing, and I can basically, with a new construction, basically use that, or does existing mean design something to a certain level, and then now that becomes existing before it gets out of the gate. So it might be an end around basically, okay, it's not just retrofits. Maybe we start using this for new applications. So there is a lot of stuff, a lot of shifting environment. Stay tuned. I mean, as best we can, we will get information out as soon as we can.
Yeah. And just, I guess, Stefan, to your question about is this viable? Do we tend to find more capacity in existing buildings and what types. Like based on my experience at AES Engineering, looking at hundreds of different buildings, capacity in them. If you've got electric baseboard heating, the large majority of those buildings would have enough capacity to pretty readily electrify everything, including having, 100% EV ready parking and add heat pumps for space heating and cooling and electrify hot water and makeup air, provided you used kind of fairly straightforward to implement and things that comply with the electrical code today, types of power efficient design strategies. So good EV energy management practices, good right sizing practices, and provided that you could access that historical load data and make use of it, which ultimately you can typically often do, but sometimes, I think the incentives aren't totally aligned if it's going to be a real headache for contractors or, engineers to get that data and provide that assessment. So when you've got those electrically heated buildings, quite possible the vast majority of the time, definitely more challenging with gas. There is still quite a bit of capacity in those gas buildings, but they just weren't calculated, like the loads weren't sized with that electric space heating in mind. That being said, is you use good power efficient design strategy, you can electrify an awful lot, if not all of that, those types of loads and provide abundant EV charging, providing you're being really attentive to the strategies that we're using. And I think it'll be quite important to enable the load control of not just EVs, but other types of equipment as well to enable that to happen at scale. So there's like promising approaches there, but that's certainly where it is most challenging, those gas heated buildings.
Thanks, Brian. I think we'll wrap this up with this. We're like 3 minutes away from the hour. I wanted to first thank you, Brandon, for walking us through the power efficient design guide and sharing those practical strategies. Right sizing first and then right sizing again. Thanks for Jeremy and Jason to participate in the conversation and in the chat and answering those questions. We'll follow up to this group with a newsletter or an email and synthesize anything that we didn't get to answer right here. I wanted to thank everyone for joining us today, for your questions. And I wanted to quickly pitch the next ZebEx Decarb Lunch coming on June 30th, which kind of ties in right to this session of today. It's called Less Oversized, More Decarbonized Hot Water in MURBs, and it will focus on domestic hot water retrofits in multifamily buildings. Again, talking about modern sizing approaches, heat pump storage, and practical BC case studies. I think Victoria has shared the registration details for this the Decarb Lunch in the chat, and we'll hope to see you there. Thanks, everyone, and enjoy the rest of your day.
Thanks all. See ya.
Thanks, everyone. Nice to see you all.